Hi, and we're going to do the lesson on seasons from Chapter 1, Lesson 2 from your Pearson Realized textbook, pages 18 to 20. The vocabulary words that we're going to do is axis, equator, hemisphere, seasons, June solstice, December solstice, March equinox, and September equinox. The reason for Earth's four seasons is the tilt of Earth's axis as it revolves around the sun. What causes seasons? Let's review. An axis is an imaginary line that a planet rotates on, and for the Earth, the axis is tilted at 23.5 degrees. An equator is another imaginary line, and that goes through the middle of the Earth, and it distinguishes and helps us to see the difference between the North and the South Pole. Let's take a look at these notes and write them down. Axis is tilted at 23.5 degrees for the Earth. At the poles, light arrives at a steep angle because of this tilt. At the equator, the sunlight hits almost overhead. Let's take a look at that from outer space. Notice for our model, the sun is in the middle. We have four positions for the seasons of the Earth. On the Earth, I have written here an N for North Pole on this part of the axis and an S for the South Pole on that part. Also, there's a darkened half of the Earth to show you where night is. This part is light to show you where day is. The equator helps us to see the difference between the North and the South Pole. Let's start with the June solstice on this side. June solstice for the Northern Hemisphere has long days and short nights. If we look here at the model of the Earth, for the top half for the Northern Hemispheres, the summer has this larger area because it's tilted in towards the sun, and you have a lot of day. There's this little sliver of night. The whole section is experiencing summer, whether it's day or night. The opposite season is happening below. This is called winter. Because the Southern Hemisphere is tilted away from the sun, it has this angle that's opposite. You have a little bit of day and a lot of night. The whole bottom half of the Earth is experiencing winter during the June solstice. During the December solstice, on this part of the model, the Northern Hemisphere has short days and long nights. Here you can see winter is because the Northern Hemisphere is tilted away from the sun. That gives the angle of the day very little amount, and the angle of night is longer. There's a lot of it. The opposite season is happening for the Southern Hemisphere. The day is towards the sun, so there's a lot of sunlight. There's a little bit of darkness because of that tilt, and it's the opposite season happening below. It's summer the entire time, whether it's day or night for the Southern Hemisphere. Notice I skipped these two Earth models here in the middle. They're called equinoxes. During the March and September equinox means equal night, the days and nights are about 12 hours. If we look at the model of the Earth from outer space, the amount of sun hitting the Earth would be about 12 hours of day, and night would have about 12 hours of night, because the angle does not matter. It's not affected by the tilt. Only the solstices, because they're tilted away for the Northern Hemisphere, it's winter, and towards the sun for the June solstice, it is experiencing summer. Thank you for your attention. If you have any questions, please let me know and I can help you.